Across the desert skyline, Troon's world-class courses have carved their legacy into the land. And now along its edge, a new vision is rising, a project built on precision, expertise, and purpose. Every great structure begins with one thing, a foundation. And no one understands that better than the Valleywide companies. From survey to pour, from dirt to design, this is where skill meets craftsmanship and where the groundwork for excellence begins. Everything begins with a survey. Before the first scoop of dirt is moved, the land is analyzed, measured, and mapped with precision. A site survey is the foundation of every successful project. It identifies the topography, existing utilities, and natural or man-made features across the property. Once the plans are drawn, the survey brings them to life, marking every point with precision so construction can begin with confidence. Using advanced instruments, surveyors establish horizontal and vertical reference points, the exact coordinates that guide every phase of construction. These points define where each structure will stand, ensuring the project is built safely, accurately, and according to design plans. By transferring design to the field, surveyors help reduce errors, prevent misalignment, and protect structural integrity from the ground up. Because before any foundation can rise, the land must first be recognized. Once the survey is complete, the groundwork for precision begins. Survey stakes are set across the site, each one a reference point tied directly to the design plans. They mark corners, edges, and elevations, turning digital drawings into real-world coordinates. Every stake tells a story, where a wall will stand, where a pipe will run, where the foundation will take shape. From these markers, the crew begins the layout. Using chalk lines, they trace the outlines of future structures directly onto the soil. These white lines define the footprint of the build, the perimeter of the foundation, the rooms, and the pathways in between. This stage is about clarity and accuracy. Before any dirt is moved, the site becomes a living blueprint, each line and stake working together to guide the excavation that follows. With the layout complete and every line marked, excavation begins. But not all sites dig the same. During excavation, a standard excavator can usually cut through the native soil without any extra steps. But hillside projects, like this one, come with a high chance of buried rock or dense, compacted ground. When that happens, the crew performs what's known as a hard dig. Using a hydraulic hammer, they break through the tough layers that a regular bucket can't cut. Each strike fractures the rock, loosens the soil, and prepares the ground so excavation can continue safely and efficiently. Once the resistant layers are opened up, full excavation takes over. The machines cut into the earth, forming the depths where the foundation will take root. This is where the elevations, widths, and boundaries are shaped, creating the trenches that will soon hold the footings, the reinforced concrete pads that spread the building's weight and lock the structure into stable ground. Every cut, every scoop brings the site closer to a foundation built to last for decades. With excavation complete, the crew begins shaping the foundation's outline. Form boards are set along the edges of the site, each one positioned and adjusted with precision. These boards define the exact perimeter of the future structure's foundation. The team checks distances, angles, and alignments, ensuring the layout matches the plans down to the inch. Every measurement matters. Stakes are driven deep into the ground to support the forms. Once anchored, screws lock the boards to the stakes, creating a rigid frame that won't shift under pressure. The forms must be strong enough to hold back the weight of wet concrete and accurate enough to guide the rest of the build. Every board, every stake is set with intention to ensure the foundation takes shape exactly as designed, creating the mold that will define the structure's first solid form. After the perimeter forms are secured, the next phase focuses on installing the under-foundation utilities, the systems that will support the entire structure. These include plumbing, electrical conduit, and any required underground air handling ducts. The black pipes laid across the site form the plumbing network, carrying drainage and waste lines throughout the foundation area. Each pipe is positioned at precise depths and slopes to ensure everything performs exactly as designed. Electrical conduit and any necessary air handling pathways are installed during this stage as well, completing the full utility layout beneath the foundation. Once all utilities are set and inspected, a layer of bedding sand is added around the lines. This locks in the slopes, cushions the pipes, and protects them from rocks or shifting soil before the base material goes in. With everything placed and approved, the under-foundation utilities are complete. After this point, nothing can be adjusted. Once concrete is poured, these systems are permanent. The crew now moves on to prepping the pad. Before anything goes down, the native soil, the subgrade, is compacted. This tightens the ground beneath the foundation, increases its strength, and prevents future settling once the weight of the building is on it. After the subgrade is compacted, the aggregate base course, or ABC, is brought in. It's a layer of crushed rock made up of stone, gravel, and fines like sand. The crew spreads it across the pad to create a consistent, level surface. Once the ABC is in place, it gets compacted as well. Using a remote-controlled trench compactor, the crushed rock is pressed into a dense, uniform layer. This locks the stones together, forming a rigid base that spreads the load of the structure evenly across the stabilized soil below. Together, the two layers of compaction create a strong, unyielding platform that keeps the structure from shifting or settling over time, protecting the integrity of the concrete and everything that will be built on top of it. After the elevations are checked and the base is complete, the pad is now ready for the next phase, installing the rebar. Now that the base is compacted and the pad is set, the next step is reinforcement. Rebar is added because concrete is extremely strong in compression, but weak in tension. Without reinforcement, the slab would crack or fail anytime the soil shifts, the building loads change, or the structure flexes under weight. The process starts with the continuous footings. These run along the perimeter and under major load-bearing walls. They use a steady pattern of rebar that helps the foundation resist tension and spread weight evenly across the ground. In areas where the structure will carry heavier, concentrated loads, enhanced footings are placed. These zones use more rebar, arranged tighter and in multiple layers, giving them the strength needed to handle higher stress without cracking. Across the entire pad, the steel is tied together to form one connected reinforcement system. This network controls cracking, increases resistance to bending, and locks the concrete into a strong, unified structure. Once the reinforcement is tied and complete, the foundation moves into the next critical steps: inspection and termite treatment, the final checks before any concrete can be poured. Before concrete can be poured, all third-party inspections must be completed. Additionally, two important steps take place: the pre-pour inspection and the termite treatment. The pre-pour inspection comes first. A building official walks the entire foundation, making sure everything matches the engineering plans. They check elevations, formwork height, slab layout, and every utility or sleeve coming through the pad to confirm they're in the correct position and properly protected. Once the inspection is approved, the soil is treated for termites. A chemical barrier is applied across the pad and around the foundation perimeter. This treatment soaks into the top layer of soil, creating a long-lasting shield that prevents termites from tunneling up into the structure in the future. It's a preventive step that protects the building for years before any wood ever goes in. Once both steps are complete, the foundation is officially ready for the concrete pour. Now comes the concrete pour. The moment the foundation goes from preparation to reality. You'll see all 4 pads get filled, each one flooded with a continuous stream of concrete that locks the entire structure into place. Concrete isn't just dump it in and smooth it out. It's a controlled, engineered process. The mix has to flow through every beam, wrap around every rebar cage, and settle without trapping air pockets. That's what gives the slab its long-term strength. Whether it's early morning or still dark out, the crew keeps the pour moving nonstop. A continuous pour prevents weak spots and lets the slab cure evenly as one solid piece. Once the concrete lands, it's leveled, edged, and floated to the exact height the plans call for. This is what creates that perfectly flat surface the entire structure will rely on. And as the pours finish, the site transforms. From above, you can see the project taking shape. Some slabs freshly poured, others already setting. The first permanent milestone now locked into the ground. The foundation is officially complete, and this is only the beginning.